Hey guys, welcome to my channel. I'm Jenny Cover. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have an amazing problem. So let's go ahead and read the problem statement. So it says that find players with 0 or 1 losses, right? So it says that we're given an integer array, right, called matches. Or it's gonna be a 2D array, right? It says where every array, right, it's gonna have two things in there, right? So a winner and a loser, right? So the first index is gonna be the winner and the second index is gonna be the loser, right? It indicates that player winner defeated player loser, right, in a match, right? So it says return a list answer of size 2, right, where the first list is gonna have all the players that have not lost any matches, right? So they're undefeated, right? And then we have a second index, right, where pretty much we need to keep track of all of the it needs to contain all the players that have lost exactly one match, right? Not two, not 0, but exactly one match, right? It says the value in the two lists should be returned in increasing order, right? So it should be sorted. So that's what they're saying, guys. So it's very, very important, right? Say you should only consider players that have played at least one match, right? It says the test cases will be generated such that no two matches will have the same outcome, right? So this is very interesting, right? Okay. So it needs to be exactly one match. Okay, cool. So how can we solve this problem, guys, right? So let's go through a couple of examples. So we're given this whole, like a lot of lists, right? We're given this list, right? This 2D array as input, right? And then so we see that so those are all the ones that have lost like 0 matches, right? So they're undefeated, right? This are all of the ones that have lost one match. You see players 1, 2, and 3, and 10 haven't lost any matches, right? And those other players, right, they have lost like exactly one match, right? That's where we return those right there in the second one. And then those other players, right, they didn't make it to any of those lists because they've lost like 2 matches or more, right? So yeah, so because of that we don't include them in the output results, right? So yeah, and this is this other example, right? So we see that so 2 beat 3, right? So by looking at it, 2 beat 3, right, and then 1 beat 3, right? So we already know 3 is not gonna be included, right? And then 5 beat 4, and then 6 beat 4, right? So 3 and 4 are not gonna be included, but 2 is gonna be included, 1 is gonna be included in the first one because they haven't been beaten, right? They're undefeated. And then 5 as well, right? And also 6, guys, right? So that's why we have them in there, right? You can see that we have nothing in the second list because we don't have a player that have lost exactly one match, right? We have, right? Because of that, there's nothing in there, right? So you can see she's getting kind of interesting, right? So how can we solve this problem, guys? What kind of intuition that we need to solve this problem, right? What can we do? So just kind of think about it in a little bit, right? So we see that we're giving a bunch of players, right? And then we have a bunch of players and some players they beat other players, and so we need to find a way to keep track of everything, right? So it's kind of interesting, guys. So the intuition behind this problem that can probably solve, guys, we could probably model all the players, guys, could model this as a graph, right? So pretty much all the players are going to pretty much represent nodes in the graph, right? You're going to represent vertices, right? And now we need to show the relationship between the different nodes in the graph, right? You know what I'm saying? How can we do that, right? So the relationship that can be formed, right, between them, or that so what we could do to represent that a particular node, right, beat a particular player beat another player, right? We could pretty much show that by having a directed edge, right? So for every so we're gonna be giving it those kind of matches, right? Pretty much that tells us the outcome, right? So winner would point to a loser, right, to signify that that this node beat that node, right? So that's kind of the relationship that we have between the two nodes, right? So pretty much you could kind of think of this matches array, right, as some kind of uh pretty much edges array that pretty much tells us the relationship between the two different nodes, right? The two different players. So reading this, right? So see for this one, right? 1, 3, 1 will point to 3 to signify that 1 beat 3, right? And then we keep building the graph as in such a manner, right? Like in 2 beat 3, right? After we fully build the graph, guys, this is gonna help us and be able to create our output result, guys. So once we build the graph, right, you know, we build it as we said just now, right? Now for the first one, right, we could easily say, all right, cool. So pretty much we know about the concept of n degree, right? Because we talked about topological sort on this channel before, right? We've also talked about, we also did this other problem, like found the town judge, guys, where we talked about the n degree of a node and the out degree of a node, right? So n degree of a node is pretty much talks about, you know, the amount of edges coming into a node, right? That's the n degree, right? And the out degree is the amount of edges coming out of a node, right? So for this problem, all we care about is the n degree, right? The amount of edges coming into a node, right? So pretty much after we build a graph, right, we see that all the nodes, right, that have n degree of 0, right? Pretty much no other player as being them, right? So we could easily keep track of that, right? We could loop through the graph, right, and then find all the nodes with n degree of 0, right? Pretty much nobody beat them, right? So we put them in the list, right? And then we do the same thing, right? We loop through the graph. We also keep track of we add all of the what's it called, all the nodes with n degree of 1, right? We signify that they've lost one match, right? Exactly one match. So we just add them in a list, right? And then we are pretty good. Just like that, we can get our answer, guys. You know, we model everything as a graph, right? We the players represent the vertices in the graph, right? And we got the edges, right, which connects them to each other. Right? It's gonna be a directed edge, right? Pretty much going from another player to the other player, signify that player for, say, edge UV, right? So U would be the winner and V would be the loser, right? And we keep modeling the graph and stuff. So I'm gonna show you guys visually how it's gonna look like, guys. So this is the first example, right, that's given to us, guys. So this is right here, right? So we have this input matches, right there, guys. And then so pretty much I took the liberty of going and drawing out the graph before, right? So pretty much we see that see 1 and 3, right? So 1 is pointing to 3 to signify that 1 beat 3, right? So that's taken care of. And then we see 2 points to 3, right? That's taken care of. And then 3 points to 6 because 3 beats 6, right? As you can see from this thing that's given to us, right? You see how we're building the graph based on the information that's given to us, right? So we could easily see this as a edges array, guys. So pretty much then we build the graph as such, right? And then we see that 5 points to 6, right there, right? Because 5 beats 6 and then 5 beats 7, right? Okay, we have this right there, right here. And 4 beat 5, right there, right? Okay, and then we have 4 also beat 8, right there, right? And then 4 beat 9, right? I have this right there, all right? And then 10 beat 4, right? So we keep track of that. And then 10 also beat 9, guys. So we've pretty much visually represented the graph, right, that's given to us, right? So so after we do that, right, you see how easy it is, right? So we see that the first list, right, contains all the nodes that haven't been bitten, right? So the node that haven't bitten, right, we can see that the n degree of them are 0, right? Because there's no other nodes are pointing to them, right? So we have 1, right there, right? We have 1, right? Well, we have 2, right? 2 because there's no other node, right? N degree 0, and then 10, right? That's it. And then every other node have something pointing to them, right? So that's why exactly what I'm saying. And then we have the second one, right, where there's exactly one edge coming into it, right? So the nodes are 4, that's a good one, right? 4, 5, right? That's another one, right? Because that's just there's one edge, right? Let me see, 7, all right. Okay, what else? Okay, no, 6 cannot be it. Nope, 8, right? Yep, 80 is it, right? So that's why we end up returning, guys, those as the part of the second list, right? So hopefully you guys kind of get the intuition, right, and get understood the thought process that I'm trying to convey to you guys. So let's quickly now go into the code, guys. So it should be relatively straightforward, guys. So I have a playlist on graphs, guys, that talks about how to represent graphs. I'm saying either agency matrix or agency list, right? So we're gonna be using agency list, guys, because that's how we've been doing a lot of those problems here. So we're gonna keep it consistent, right? So yeah, so right now, so let's quickly do that, right? Okay. So we're gonna have a map, guys. So a map, so it's just me representing the graph agency list, guys. So make sure you guys go through that playlist, right? That talks about all the different basics, right? Stuff like that, guys. So I'm saying, so the playlist is coming along pretty good, right? We gotta talk about a lot more stuff on that playlist, right? So I'm gonna be adding a lot more stuff. So yeah, so pretty much, so we also need to, guys, keep track of. So this is gonna pretty much help us build the graph, right? And now we need to keep track of the end degree, guys, right? End degree is gonna be very important, guys. All right, cannot stress that enough, right? All right, because it's gonna easily help us in getting our solution, right? Okay, so we have end degree, right? So now we have int. So m match, right? It's called a match. And matches, right? So right now I'm having this step right now, right, just to initialize the graph, right? So we call it match. So it's u and v. So I'm just do end degree. This is just me initializing the graph, right? So you make sure everything's in there, tripping, right? So and also need to do g.put u new array list, right? So this is just for me to initialize, right? Then we're gonna build the graph pretty soon, guys, so do not worry about that. So we're gonna do the same thing for v, right? We're just making sure everything's it's been initialized, so everything's good. But now we're gonna build the graph, guys, right? So just the initialization step, right? So let's, are we good so far? So right now I'm gonna rename everything, right? So the winner, right, and loser, right? So if you guys all following what I'm doing, right? So it's pretty much initializer, right? So we get a 2D array, and then we just are pretty much making sure everything, is in the graph, right? Everything's in the end degree, so that we're in good shape, right? Once we're referencing them, so we don't get any null pointer stuff, like those weird stuff, guys. So let me sure I get everything, man. It seems like all right, cool. So now that we get a winner. So the first index is the winner, right? And the second index is the loser, right? Because that's what they said, guys. That's where I got it from, right? So now let me erase that. So now we're gonna build a graph as we said, guys. So we do g that get, guys. So we're pretty much gonna, so the winner, right? Right, winner that add, right? We add, guys. What we're gonna do, we're gonna add the loser, guys, right, to our list, since now we're pointing to it, right? So you see how we're representing graph using adjacency list, guys. So if you don't know what I'm doing, I highly advise, right? So this is very basic stuff, right? That I'm doing right there, guys. So okay, and then now since the loser just got a new node pointing to it, right? So it needs to update its right? It needs to update its end degree by 1, right? So that's very important, guys, right? So end degree loser, and you put that end degree, and it gets incremented by 1, right? So it say if it was 0 before, it gets +1 to increment it, right? So go watch my topological sort video. I went into that in detail, right? So yeah, so now the graph should be built right there, right? And then let me see what's next for us to do, guys, right? So they want the output result, right? Kind of like that, right? So they want 2 lists, guys, right? So we do want a list of lists, guys. So let's initialize our output, right? Right, let's initialize our output. So let's call it res, right? And then we do new array list, right? All right, so that's gonna be the thing that we're gonna return, guys. Right? Let me just go ahead and return result. Right? So we're gonna have that, right? In the meantime, we're also gonna need, guys, right? Kind of two lists, right? You know what I'm saying? So let's call it a list of integer. Call it temp1 undefeated, right? All right, undefeated, right? So pretty much this one's, guys, is gonna pretty much be all the nodes with n degree of zero, right? Because no other player has beaten them, right? So their n degree should be 0. I'm saying, and then we have this other list, right? Which is the what's it called? It's almost undefeated, right? Because those ones they've lost exactly one match, right? So they were so close to being undefeated, right? So we have those two lists, right? So pretty much the n degree of those almost undefeated, right, are gonna be kind of, gonna be 1, right? Exactly 1, guys. So okay, let's create some space. Make sure that it's clear for you guys, right? So now we're gonna loop through all the nodes, guys, right? The key set of the nodes, actually, right? So add node and g that key set, right? Right, g that key set, right? So what we're gonna do, guys, we're gonna pretty much do a check, right? So if n degree that get node, right, equals to 0, right? Equals to 0, then the undefeated so it's gonna get added to the undefeated list, right? Because they haven't been beaten yet, right? So yeah. And then the other case, guys, right? If the n degree is exactly 1, right? It needs to be exactly 1, guys, right? Then we add it to the almost undefeated list, right? So yeah. So we add that in there, then those two lists should be taken care of, right? And then now, after we do that, guys, we add the undefeated first, right? Because they said that the first index should have any output results, right? Should have, right? That's what they said right there, right? Should have all the players that have not lost any matches, right? So yeah, and then the second index, right? The next one is gonna have exactly all the players that have lost exactly 1 match, guys, right? Let me know if everything makes sense, guys, right? Try to explain it to the best of my ability, right? Let me give me some feedback. Let me know what you guys want to see, guys. So it seems like we got everything under control. Let's press run code to see if we got anything, guys. Let me see. All right, array lists. I don't know how to spell anymore. All right, looks good so far, guys. Let's press submit. See if we pass all the test cases, guys. Oh yeah, I forgot one important thing, guys. Let me see. I think I'm missing one important thing. Let me see. I said that it needs to be sorted, guys, right? Which is going to be a very, very important step that you cannot forget, guys. So undefeated. So it gets sorted, right? And then we need to do the same for the thing, right? For almost undefeated, right? So I think after that we should be good, right? All right, right? So let's press submit. I think we should be good now. Awesome, guys, we are good. Everything's all right. We passed all the test cases, guys. So yeah, I want to thank you guys for taking the time to watch this video, guys. If you guys found value, make sure to give me a like, and if you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.